Okay, so let's solve this. Let's try a lead code question. Okay, so let's try this question today. So sort array by increasing frequency. So given an array of integers, nums, sort an array in increasing order based on the frequency of the values. Multiple values of the same frequency, sort them in descending order. Okay, so the problem statement looks straightforward, but I think it becomes very clear with an example. Let's look at the first example here. You can see that, if the nums array is 1, 1, 2, 2, 2, and 3, so the frequency of 1 is 2, right? So I'll just like to illustrate this, let me just write, for example, 1. So the frequency of, 1 is 2, and 2 is 3, and 3 is 1. So in that case, the element 3 has a least frequency. So because of that, it will appear the first in there, and there's only one 3, so it appears only once. But then there are two ones, so it will appear twice like this, and it's the second lowest frequency. And then there are three twos, so that's the last one, and there are three of them. So that is why the result is this. Right. But I think the second example is a more interesting one if you look at it. Like in the second example, there are two twos and two threes, and there's only one one. So that's why we have a one appearing first. But then because there's a tie in frequency for the element two and three, uh, so what they want us to do in that case is they wanted to sort it in decreasing order. So that's why three appears first and two appears after that. Okay. So basically, the idea is first to get the frequencies of all the elements, and then what we need to do is like sort them in the frequency order. Okay. So you do that, and if there's a tie, we also sort them in decreasing order of the item itself. of the key or item, whatever itself, right? So yeah, that's basically the thing that we will do in this question. So what do we do? So first we have to get the frequency of elements. So in Python, there's a very direct way to do this. So what you can just do is like apply this collections.counter, and if you do a nums here, so here we have actually got this counter dictionary, right? Okay, so now I'll take a result list, empty result list, and what I'll do is I'll just loop through the counter, so counter.items. Oh, okay, sorry. So what we'll now do is actually sort this counter values, right? So, okay, so now what we'll do is we'll just sort this, okay? So let's take there's a list is equal to counter dot items. So what this will do is it will give you the tuples basically of the number and its frequency. And we would want it to be in a list form so that we can sort it easily. Okay. Now we would actually sort this list. So it's list.sort, and the key would be so we have basically got tuples of this number and its frequency. So the key would actually be the frequency of this. But if there's a tie, we would want it to be also sorted on the value itself. But then not in increasing order, it will be in decreasing order. So that's why you do a minus x0. Okay. So yeah, just convince yourself that minus x0 would work. It's basically a way to do a decreasing sort, right? Okay, so once the sorting is done and we have a rest, we have an empty res prepared for us, what we'll do is so we'll just go in for x comma frequency in lists, right? So now the thing is, see, we don't just want the value, we actually also want the value to be repeated as many times as its frequency. So what we'll do is we'll actually create this temp list. What this is basically a list and multiplied by its frequency. And see, it is sorted so in the proper order already, the list. Okay, so and then what we do is just extend our lists. So that just means that we kind of made this temporary list and just kind of put it in our final, oh sorry, this should be res, in our final resulting list, and just keep on doing that. And at the end we'll just return res. Oh sorry, why is this wrong? So list dot sort key equals to, oh sorry, the should actually be lambda x such that this, I think this should work now. Hopefully, yeah, it does. Submit, and you can see it does work, and it does not, it shows it's not very efficient, but if we think of the time complexity for this, we have basically kind of created a counter here. I mean, this would be done in O of n, and this sorting would be done on O of n log n, basically. And then we are just extending this. So yeah, so basically this is like the bottleneck, like the most costly operation. So the time complexity is simply O of n log n, basically, right? Yeah. So I think yeah, probably is there a way to do faster than that? Yeah, I'm not sure actually. But thanks for watching this video. If there's a way to do it faster than this, I'll probably upload that as well.